Welcome back to part 4. In this part, we're going to look at systems where we don't have a matching coefficient. So our learning intention for this is solving a system of equations when we have to force two coefficients to match by changing one equation. Now that word changing can be a bit dangerous. We're not changing the meaning of our equation, we're just changing the way we write it. So if we look at what we've got here, if we try to ask ourselves the question of x or y, it wouldn't work. X or y, not the same. Sorry, x's we've got 2, we've got 1. Y we've got 3, we've got 1. And what this means is that we're going to trick our equations into having something the same. You may have already thought about it, and you may already have a hunch about what we can do. But how can we make 1 into 2? And the answer to that is we multiply the second equation by 2. And what is absolutely essential is you multiply all of that equation. If you only do it to the x, you've changed the fundamental meaning of that equation. Okay? So let's do it. These two equations, the first one is going to stay the same, so we've got 2x plus 3y equals 10. The second one is going to become 2x plus 2y equals 6. Now we're going to ask ourselves that question we had up here, x or y. This time, success. The x's are the same. And remember, when we circle that x, that's because we are going to get rid of our x. And to know whether we're adding or if we're subtracting, we're going to ask ourselves, do we have the same sign? And in this case, positive, positive, yes, we do have the same sign in front of that x. Same sign, we go with the alliteration, same sign, subtract. So we are going to take away the second equation from the first equation in our chimney sum style. So we have 2x, take away 2x, we get 0. That's what we expected, we wanted it to go away. 3y, take away 2y, we're going to be left with y. 10, take away 6, we're going to be left with 4. And actually, that's us pretty much done. We just need to state it a little bit more obviously. Y equals 4. Now, second step, we can't forget to do it, we have to substitute in. So we sub in. Now here's the great bit. We can go back to this original equation that we times by 2 because we haven't changed the meaning of the equation. We can just use that one that's sitting there. So we're going to have x plus y equals 3, but I know the value of y, so I have x plus 4 equals 3. And when we do change signs, we're going to have x equals 3, take away 4, equals minus 1. And I think I've just gone off screen there. So we have x plus 4 equals 3, x equals 3 minus 4 because the 4's come across, and then we have x equals minus 1. So that's how we do it if we are changing one equation. I'm going to record another example about if we have to change both equations. And it's not necessarily harder, it's just we've got to have a wee think about doing it the most efficient way.